Hello, what's up, amazing people, students, and lovers of chemistry out there? I'm excited to be here with you on yet another episode on Question for the Day. And on today's episode of Question for the Day, we have a question that has to do with Faraday's second law of electrolysis. All right, so the question says a current of 5 amperes is passed through molten lead 2 bromide for 10 minutes. Calculate the mass of lead that is deposited. Now they've given us some data that we'll be needing in solving this question. So let's go ahead and solve it step by step. So now Faraday's second law of electrolysis has a mathematical formula, and that formula says that the mass of a substance deposited M is equal to the molar mass of that substance times the current I times the time T divided by the number of electrons involved in the reaction multiplied by Faraday's constant. All right, so now that we have our formula in place, let's go ahead to impute all the variables and get our answers. So M will now be equal to, this over here is 207 grams per mole multiplied by I stands for current, and they told us that a current of 5 amperes. So we have 5 times, now we have T. T was given to us as 10 minutes. In electrolysis, we measure our time not in minutes but in seconds. So we'll just do a quick conversion. We want to convert from 10 minutes to seconds. So to do that, we simply say 10 multiplied by 60. When we do that, we end up with 600 seconds. So now that we've done that, let's impute it into the formula. So we have multiplied by 600 divided by N. Here stands for the number of electrons that are used in the reaction, and from the equation here you can see we have 2 electrons that were used. So we have N is equal to 2 multiplied by F stands for the Faraday's constant, and they've given us to be 96,500. 96,500. I hope you're seeing how each of these steps are being taken. So let's go ahead and multiply the numerator. We have 207 multiplied by 5 multiplied by 600. That gives us 621,000 divided by 96,500 times 2. That gives us 193,000. So our M will be equal to, when you do this division using a calculator, you arrive at a figure that is 621,000 divided by 193,000. That gives us 3.22 grams of lead deposited. So the question says calculate the mass of lead deposited. We have just done that, and we've calculated it to be 3.22 grams of lead deposited. I want to say a very big thank you for staying around till the end of this video. If you enjoyed it, please like, share, and subscribe, and I'll see you in the next one.